This is 10.3, number 87, and the question is, the Sierpinski carpet is a two-dimensional counterpart of the Cantor set. It is constructed by removing the center 1/9 of a square of side 1, then removing the centers of the 8 smaller remaining squares, and so on. The figure shows the first 3 steps of this construction. Show that the sum of the areas of the removed squares is 1. This implies that the Sierpinski carpet has an area of 0. So when n is equal to 1, the side length of the square that we're going to remove is going to be 1/3 of the side length of the original carpet. And because the side length of our original carpet is just 1, the side length of the square that we're going to remove is just going to be 1/3. So the area of that square is just going to be 1/3 squared. And then when n is equal to 2, the area of this, or the side length of the squares that we're going to remove is going to be 1/3 of 1/3 of the side length of the original carpet. So that's going to be 1/9. And so the area of those squares is going to be 1/9 squared. And there are 8 of them, so we're going to multiply by 8. And this can be rewritten as 8 times 1/3 to the power of 4. And then when n is equal to 3, the side lengths of these squares that we're going to remove now become 1/27th of the side length of the original carpet. So their areas are going to be 1/27 squared. And now there are 64 of them, so times 64. And that can be rewritten as 8 to the power of 2 times 1/3 to the power of 6. So we can notice that each time 1/3 is being raised to the power of 2n. So 1/3 to the power of 2n. And when n is equal to 1, we're only removing one of those squares. And when n is equal to 2, we're removing 8 of those squares. So we're going to multiply this by 8 to the power of n minus 1. And 1/3 to the power of 2 is just going to be 1/9. So 8 to the power of n minus 1 times 1/9 to the power of n. And then now we're going to multiply both top and bottom by 1/9. So that's just 1. And then this becomes 8 to the power of n minus 1 times 1/9 to the power of n minus 1 times 1/9. And then that is just 1/9 times 8/9 to the power of n minus 1. And that's our series for the area that's like removed from like all the squares. So the total area that's going to be removed is going to be a sub 1 over 1 minus the common ratio, which is 8/9, and then that's 1. So like the problem wanted us to prove, the total area removed is 1, which implies that the Sierpinski carpet has an area of 0.